Hello, ladies and gentlemen. Root Beer here with question number 22 on the 2003 Grade 9 Pascal paper. That's the multiple choice level Grade 9 competition, not to be confused with the written one, the Friar. So, question 22. In the diagram, two circles with centers A and B intersect at points P and Q, so that PAQ is 60 degrees and PBQ is 90 degrees. What is the ratio of the area of the circle with center A to the area of the circle with center B? Okay. Well, how do we figure out areas of circles? Areas of circles, there's really only the one formula, pi r squared, where r is the radius. We've got two circles, so we're going to have to give names to both of their radii. I'm going to go with little a for the radius of circle with center A, and little b for the circle with center B. And that way I can easily tell which radius goes with which. So, one area will be pi a squared, and another area will be pi b squared. The ratio, then, they'll have a common factor of pi. It should just be a squared to b squared. So, first of all, I start looking through the answers. I notice that E is 9 to 4. That's the only one that involves two squares. I'm going to guess that's the answer before I've even done any calculations, just because it should be a squared to b squared. But maybe the radii aren't integers. Okay? So a good idea would be to now see, can we calculate the radii? Can I figure out what little a and little b are? Well, let's draw ourselves a picture and see what we can see. Okay. So, do our best to draw some nice circles. Okay, there's P, there's Q, there's A, and there's B, and they were nice enough to connect these up. I'm going to use colors here. A is our radius there, and we'll use red for B. B is our radius here, and I have a feeling we're probably going to need the fact that this here is a common length. This is called a chord. Connect 2 points on the sides or on the circumference of a circle, and you get what's called a chord. Big chords are the longest chords are diameters. So we've got 60 degrees here and 90 degrees here if I read it correctly. Yeah, PBQ 90. All right. So what can we do here? Ultimately, we're looking for a ratio of a squared to b squared. All right, specifically, we wanted pi a squared to pi b squared, but with a common factor in there, it's just a squared to b squared. Okay, now I have no idea what length PQ is, but I notice that it's common in both triangles. Okay, so I'm going to give it a name. I've got little a, I've got little b. I'm going to just call it C. And what do I notice about these triangles? Well, things I could notice. I was about to make a comment. Actually, I'll make it now. But we have enough information to relate C to both a squared and b squared using something called the cosine law. But it just occurred to me that that is usually taught around grade 10, and it's not expected on the grade 9 Pascal paper. So I was going to say, well, we can obviously just use cosine law and we're done. But, which, by the way, if you don't know cosine law, you want to get a jump start on trigonometry in grade 10 or just any time in your future, feel free to look up cosine law, sine law, trigonometry. It's great fun. Great, good stuff. I might make some videos on that in the future. Who knows? But so now I have to think of a way to do this without using cosine law. But it's a chord of a circle. So what we can do is all chords are divided in half if I drop a line from them to we get a right angle if we drop an orthogonal line. Geez, my picture's really not doing well. Okay. Gonna have to redraw some stuff. Okay, A should go. Ugh. A line from the center of a circle to the chord splits it in half when it makes a right angle. Okay, so we're going to say that that is halfway there. So we get a right angle there. Same thing with PQ considered a chord of the circle with B in it. Okay. So it actually also splits this angle. So this angle here was 90, so now we're going to get 45s here. And this angle was 60, we're going to get 30s here. Okay. So, what can we do here? I'm trying to think of ways to do this without trigonometry, and trigonometry just keeps popping up in my head. A squared and B squared, we're probably going to want to use Pythagoras somewhere in here. Okay. Oh, okay, this is a 30. So there's a 30, 60, 90 triangle. So 30, 60, 90, and we got 245s. Okay, I think we're okay now. So let's look at each of these triangles separately. So we have the right angle triangle with 245s here. So that means that it's an isosceles, so these two lengths are the same. They both have to square and then add up to b squared. So if we say call this length x, this one will be x as well. B squared is going to be x squared plus x squared, and that's just from Pythagoras. So that's going to be 2x squared. So b squared is equal to 2x squared. All right. Now if I look at let's ignore the ratio stuff. If we look at the other triangle, because I'd say what b is, but I'm just going to need b squared eventually anyway. Now let's look at the other triangle. We've got a here, and this is still going to be x. So we're going to get everything in terms of x. And it's a 30, 60, 90 triangle. And this has a very special property. All 30, 60, 90 triangles have side lengths in the ratio 1 to 2 to root 3. Okay? So if this side length here is x, whatever this is, it's root 3x. And whatever this is, it's 2x. So a is 2x. If we square both sides, we'll get a squared is 4x squared. Okay. Now, we want the area of A to the area of B. As I mentioned, that's pi a squared to pi b squared, setting up a ratio here. But that's the same as a squared to b squared, but that's the same as 4x squared to 2x squared, so we divide by the common x squared, we get 4 to 2, and that's a ratio of 2 to 1. So that should be our answer. And 2 to 1, there it is, it's right there, it's D. So that's the answer we're going to go with. Okay. And if you want to, if you know the cosine law, by all means see whether or not it all works out there as well. It should. And we're going to flip the page in anticipation of our next question, question number 23 on the 2003 Pascal.